Good morning, everyone. Hello. Good morning. Welcome to another Thursday morning. It's time for another bite-sized Buhl. My name is Carissa Cedor, and I am the producer in the Buhl Planetarium at Carnegie Science Center. And today, we're going on a very exciting journey to the edge of the universe. This is a fun show that in full we present in the planetarium. It's called The Beginner's Guide to the Universe, but we'll give you a little snippet today and some of the cool visuals we get to see. So we are going to start looking at our sky from Earth. You can see our stars. And for a long time, a view of the night sky was what we had to look at. For thousands of years, humanity's been looking at these same stars, putting their different stories and legends and heroes up into the sky. But a lot of people also used to think that these stars were suspended on a sphere that surrounded the Earth and that we were at the center of everything. And it took until basically until the invention of the telescope to realize that that was not the case, right? That the planets are in orbit around our sun, that the universe doesn't really have a center. So that allowed us to learn a lot more about the universe around us. So we are actually going to leave Earth today and take a journey outwards, where we're used to looking at our night sky, but let's see what else we can see. So let's take off from the Earth here. As we do, we'll see our city lights fall below us and our beautiful planet, our beautiful blue Earth. We can head out into Earth orbit here. Now, as we get further away, we'll start to see our closest neighbor in space, our moon, will come into view. And this is our moon Earth system, right? This is our neighborhood that we're used to here on Earth. Now, our moon is on average about 240,000 miles away. And this line shows you the furthest that human beings have ever traveled out into space. So we've sent people to the moon, but we have yet to cross this line. We've barely stepped off our front porch as far as human exploration goes. But we know a lot more about our universe thanks to lots of robots and probes and satellites and even telescopes that are here on Earth or that we've sent out in space that are exploring the universe and helping us map things out. So we're going to take a look at some of that data today, take a look at some of that information that we've learned thanks to all of the different kinds of exploration we've done. So we're going to head out and view our solar system. And you see there's the orbit of our Earth, but of course we've got our other planets as well. And right here we can see our inner solar system, those rocky planets that are closest to the sun. Now, closest to the sun is Mercury, the smallest planet of them all, and it has lots of temperature fluctuations actually on its surface. Since it's so close to the sun, that daylit side gets to about 800 degrees Fahrenheit, but it's very cold. It has no atmosphere to trap that heat. So it gets to minus 300 degrees Fahrenheit at night. Now, the second planet from the sun is, of course, our planet Venus here. Venus is about the same size as Earth, but it's very different, right? It's covered in clouds. And that's a runaway greenhouse. It causes a runaway greenhouse effect that traps heat from the sun, making Venus the hottest planet, 900 degrees Fahrenheit day and night on Venus. Now, we can breathe easy on the third planet from the sun, of course, our beautiful home, the Earth. The Earth lives in an area around our sun called the habitable zone. So we're at a distance from our sun where we're not too far, not too close. It's not too hot, it's not too cold. Conditions are just right for life to exist. And of course, the fourth planet from our sun is Mars, the red planet. It's a dry, dusty planet, continuing target for space probes and robotic rovers, and eventually human exploration as well. Mars lives on the very edge of that habitable zone. And we know that Mars used to have liquid water on its surface. And we think that maybe it may have once been able to sustain life. We're looking for microbes on Mars. So that's why we continue to explore the red planet. Now, between the orbits of Mars and our outer gas giants, there's a region of our solar system called the asteroid belts. Hundreds of thousands of asteroids out here. These are ancient space rocks. They're made of the same stuff that we found in our early solar system. So we can see kind of these little time capsules to the very start of our solar system out here in the asteroid belt. Now, after the asteroid belt, we have our outer planets, our gas giants, starting with Jupiter, the largest planet of them all. You could fit 10, it's 10 Earths side by side across the center of Jupiter. You could fit 300 Earths inside. It is massive. And it's made mostly of hydrogen and helium gas, very similar to what our sun is made of. Now, after Jupiter, the largest planet in our solar system, we've got the second largest, and that is Saturn, of course, famous for its rings. Those rings are about 175,000 miles from side to side, but on average, they're only about 30 feet thick. So they're very thin rings made of particles of rock and ice and dust that are actually in orbit around Saturn. Then we have everyone's favorite one to say, this is Uranus. Uranus is another ringed planet, not quite as vibrant as Saturn's rings, but still pretty spectacular. And it's actually tilted on its side due to a collision with a small planet-sized object a long time ago. So Uranus actually almost perfectly spins around on its side, and its north pole is always facing the sun. And we can see after Uranus, we've got Neptune here. Oh, Neptune just went off screen. Neptune is our, let's bring it back. Here it is. It's a beautiful blue planet. Very windy planet and very distant, right? Neptune lives about 2.8 billion miles from the sun. So it takes 164 Earth years to make one orbit around the sun. So we get a good look at our solar system here. And besides the 8 major planets, we've got an area past Neptune called the Kuiper Belt. This is a ring of rocky, icy objects. Some of them are big enough to be round, but most of them are pretty small. This is called the Kuiper Belt. And besides the 8 major planets in the asteroid belt and the Kuiper Belt, we've got other objects in our solar system called dwarf planets. Now, our dwarf planets most of them are out in the Kuiper Belt. There is one in the asteroid belt called Ceres. The rest live out past Neptune. But of course, we would be remiss not to mention everyone's favorite Kuiper Belt object, and that of course is Pluto. There it is. Now, for many years it was questioned as to whether or not Pluto should be called a planet. One of the reasons is that it's not in the same plane. You can see the orbit of Pluto is a little tilted compared to the 8 major planets. But also, astronomers in the 90s started finding a whole bunch of other things out in the neighborhood of Pluto. Lots of other kind of big things out there. Not quite as big as the rest of our major planets, but almost as big as Pluto. It's actually the discovery of an object called Eris, which is very similar in size to Pluto, that really forced astronomers to kind of think about what it means to call something a planet. So they came up with this new category of dwarf planet, and Pluto fits much better in that category. And it's kind of the cool thing about science, right, is the more information we learn, we can kind of adjust how we define things, because these definitions are made up by us in the first place, right? Nature didn't tell us what is what. So we can adjust for new information that comes in. So it's always exciting to see that happen, especially when we're looking at astronomy. All right, so we're gonna head out. We're still in our solar system, but we are getting further away. We're gonna head out into an area called the Oort cloud. This is a spherical shell of icy objects that surrounds our solar system. What we're looking at are trillions of comets. This is where comets love to live. It's very dark and cold out here, this far away from the sun. And that is conditions that comets love. Now, every so often a comet might get bumped towards the inner part of our solar system, and that's when we see them fly by, when we see them in our skies. But for the most part, they hang out here in the Oort cloud. And we are at a distance right now of about 1 light year. So a light year, when we're talking about distances in space, when we're measuring distances in space, we can't use miles because space is really big. So we have to use a unit of measurement called a light year. And that is the distance that light can travel in 1 year. Now, light takes time to travel. We don't really notice it on Earth because we're all very small and close to each other. But as we start looking further away, we notice light travel time. Our sun, it takes light 8 minutes to reach us from the sun. And the further out you look, the longer it takes, right? So from way out here at 1 light year away, the light we're seeing from our sun is 1 year old. And that works the other way as well. The further we look out in space with our telescopes, the further away an object is, like distant galaxies, the longer that light has had to travel. So the further out in space we look, essentially the further back in time we're looking. So keep that in mind as we continue traveling outwards today, because light from these more distant objects has had to travel a lot longer. So we're going to take another look at our constellations from here. Our constellations we see from Earth are stick figures, right? Our familiar pictures, even from this distance, look like the stick figures we see from Earth. But we know that all the stars are different distances from each other and from us. And as we get further out, our constellations start to warp a little bit and change. So our constellations cease to really have any meaning once we get out into interstellar space. So we're looking at these bubbles now. What we're looking at are a sampling of exoplanets. These are planets around other stars. So what we're looking at are other solar systems. And there are lots of other solar systems out there. In fact, there are more planets than stars in our universe. There are planets absolutely everywhere. So this is just a very small sampling of, there are over 4,000 confirmed exoplanets right now, and that number grows every single day as astronomers scan the skies, plotting out these planets. Now, most of these ones that we have here are uninhabitable gas giants like Jupiter. But what is being looked for essentially are there other Earth-like planets out there? Are there other habitable planets that maybe could sustain life on them? And the answer is yes, there are actually quite a few. In fact, a good percentage of planets around other stars could be habitable. It's an estimated about 1 in 6 possibly could sustain life on their surfaces. Now they're very far away, so we may not be able to contact them, but it's very exciting to start to look for these things, all by analyzing starlight. We can figure out if a planet has an atmosphere by light that travels through its atmosphere from its star in the background. So it's very cool, the different methods that are being used to find exoplanets, and there are a lot out there. And this is something that's going on all the time. This is very current science. So this is all still pretty close to home. And we're going to take a look at, maybe we're going to take a look. It looks like my computer may have just frozen. Let's see if we can get our image back here. It takes a lot to load the universe. Come back to me. Let's see here. Well, we may have to end our tour at our exoplanets today. And perhaps on our next bite-sized Buhl, perhaps on the next one that I join you for, we can leave from here and see what else is out there. Because we have gotten to a distance of about 50 light years away from Earth, 50 to 60 light years away from Earth. So we're looking out still within our galaxy here. We are still within the Milky Way, and we can head further. There's a lot more to see. So to see the rest, you can either tune into another bite-sized Buhl with us or come visit us at the Science Center. The Science Center is open right now. You can come into the planetarium and see what there is to see. We'll be showing things a lot like this Beginner's Guide to the Universe, and as well as our star shows that we have. So you can come and visit us sometime. But for now, I believe my computer has decided that it's the end of today's bite-sized Buhl. So we'll leave you with a cliffhanger, but thank you all so much for joining us, and go out and look at all the things you can see right now in our nighttime sky. We can see the planet Venus right after sunset, and you can also look for Jupiter and Saturn that are rising right after sunset as well. So go outside and see what you can see. Let us know and come visit us. But for now, I will bid you all farewell. So thank you all for joining us.